Hey, hello everyone. Welcome to the fifth video in this series. So, in this program, we'll add plots. Okay. In the previous program, we had read the data from the CSV file and we had created value boxes for sales, total sales, profit, and the number of orders sold for the particular category, number of products sold. In this program, we'll plot that data. We'll create two plots, one for sales and another for profit. Okay. The only new library that we are using here is Plotly. Plotly is used to create the plots. And here, the initial part of the UI is exactly the same. What new thing we are adding over here is this particular fluid row, which contains the two boxes. First box will contain the sales plot. Second box will contain the profit plot. We create a box with width equal to 6 and it will be of type Plotly output and the internal ID will be sales plot. Second box also will be of width 6, again of the type Plotly output, but its internal ID will be profit plot. Now, the only significance of writing 6 over here is it does not mean 6 inches or centimeter or any particular unit. It simply means that both these boxes will be of the same dimension, same width. Okay. So let's move on to the server functionality. Initial functionality of the server, the initial part is exactly the same, so I'm not explaining it again. You can go to the previous video and you can check. Okay. We discussed this part when we read the CSV file. We discussed this part when we created the drop down menus, and we discussed this part when we created the value boxes in the previous program. Now let's focus on the plots. Okay. So firstly, as you can see, we have two output fields, basically the boxes that we created just now, and we gave the internal ID, sales plot and profit plot. So we are referencing these boxes with these internal IDs. So amongst the output fields, access the output field with the internal ID sales plot. And we want to render some plot. So render plotly will render a plot, and where will it assign that plot or where will it render that plot? It will render it to the output field with the internal ID sales plot. Now what we are rendering here inside the render function, we have the requirement, the required criteria check. Basically, the filter data should be non-empty. Now, the first thing that we are doing here is aggregation, and we create a summary. Okay. So again, we are creating a pipeline. So again, if you have watched all the videos in the series one after the other, you must be aware of this pipeline operator from dplyr that we are using. So filtered data is pushed into the pipeline that is subjected to group by category. So the rows will be grouped by their category. Okay, so if there are three categories like it is in our example, so all the office supplies rows will be grouped together, all the furniture rows will be grouped together, and all the what was the third category? Whatever third categories, those rows will be grouped together. Okay. Now we'll summarize. Once we have created a group of office supplies, once we have created a group of technology, that was the third category, and once we have created a group of furniture. So when we have created these groups of rows, we want to take the sum of a particular column in that row. So that particular column is the sales, because we are creating a sales plot. We want to take the sum of the sales of all the products which fall in that particular category. So by that, in df we'll get, now make sure to notice here or just observe carefully that we are not using the pull function over here. In the previous programs or in the previous part, if you see, we had used the pull function. Pull will only keep a particular column. In this case, we are not using pull. So this is a data frame essentially. This is not just one number. So along with the aggregation of sales, the other attributes will also be retained actually. What will be the other attribute? That will be category, right? So what is the category and what are the total sales for that particular category? Then we'll use the plotly function. So plot underscore ly. this function will actually create the plot. It will use the data frame that we created just now. It will take the category column on the x-axis. So x equal to tilde category. So tilde category means that from the filtered data, from the data frame that we are using as the first attribute, take the column category. Tilde means take the column category and use it on the x-axis. Take the sales column and put it on the y-axis or use it as your y-axis. The type of chart will be a bar chart, and color will depend on the contents of the category column. What colors you want to use for each category, defaults will be used. Okay. Of course, I encourage you to explore this further. And if you want to assign a particular category, a particular color, etc., I'm just introducing you and inspiring you to explore this further. I'm introducing to the core functionality of Shiny. Okay. Now, again, we are creating a pipeline over here, as you can see. So after you create a plotly plot, okay, subject it to the next function. Okay, it goes into this separate pipeline of its own. Again, this pipeline is separate. Don't confuse these things. This pipeline is separate. This pipeline is separate. So here we are putting the plot itself into the pipeline, and we are giving it to the title. Basically, we are giving the title to the plot that we created just now. So we give it the title sales by category. Okay. And we are using the layout function to give this title to the plot. So it's like we are subjecting the plot that we created using plot underscore ly to the layout function. Okay. Or in other words, we can say that this plot that we created here becomes a parameter for the layout function using this pipeline operator. I hope this is clear. Similarly, the second plot will be created for the profit. Again, we have the requirement that the filter data should be non-empty. I think I need not explain this again. We have created another box which has the internal ID profit plot. So whatever will be rendered over here will be rendered in that particular box. Okay, and we require the filter data to be non-empty. We create a pipeline. We are taking the sum of all the profits. After taking sum of all the profits, we are doing something else over here. We are using top n. Okay, so what we are doing over here is here we are grouping not by region or category, we are grouping by the product ID. Okay, so for example, let's say there are 20 products named simply. For our simple case study, let's say they are named simply as product 1, product 2 up to product 20, let's say. Okay, so wherever you get product 1, all those rows will be combined together. All the rows which have product as product 2 will be combined together. So you'll have 20 groups over here, right? And then you will summarize profit equal to sum profit. So because there are 20 groups, 20 products from product 1 to product 20, let's say, so there will be 20 such summaries or summarized rows, right? What will those have? The product ID or name, that is product 1, product 2, whatever, and what were the total profits earned for that particular product. Okay. Now, if you have 20 or 30 such products, let's say, we only want the top 10 products out of these. So top n will only keep the top 10 rows. And what will, so first parameter that we're passing is 10. Top n is the function name. First parameter we are passing is 10. That means only the top 10 will be taken. And what will the deciding factor to decide which are the top 10? That will be the profit. So profit, you can say variable or this new column, dummy column that we are creating, basically profit equal to sum profit. Actual column was profit. We took the sum and assigned it to profit. So now profit contains the sum of the profits. Okay. So this profit column that we are taking will be the criteria. So top 10 products, we can make it top 5, top 3, whatever we want. Okay. And this is the first part. This is the data frame. And now we'll pass this data frame to the plotly function. On x axis, we'll take the products. On y axis, we'll take the profit. Type will be a bar chart. Color will be based on the profit. Now, here it's slightly tricky. It will be ranges. Okay. So, because it's a sum. Okay. So, let's see how the output looks like. Every sum of the profit will have a different color in this case. And then we are subjecting this to, or we are passing this plot to the layout function. So x axis equal to list, title, product, which are the top 10 products that we selected to be a part of this plot. And finally, using shiny app UI comma server, we launch this app. Okay, so I hope all this explanation was clear enough. Now let's go ahead and actually upload the CSV file to see how it gets analyzed. Okay, and let's maximize this so that it is clearly visible. So let's understand this output that we are getting over here. Firstly, we have the value boxes with the icons of dollar, chart, and cart as we had discussed in the previous video. Here we have the region category. Initially, all the categories have been selected. What do we see in the first plot? Sales by category. So furniture sold 3,893 units. Office supplies sold 10.668 thousand units, and office supplies sales were 15.911 thousand rupees or dollars or whatever units are used over here. Okay. Color code was assigned by them depending on the category. Okay. Now let's focus on whatever options we have over here. Okay, on the y-axis you have sales, and on x-axis you have category with the different categories listed. Now, first thing you have is you can download the plot using PNG. You can zoom in and you can zoom out. You can pan. Basically, you can move the chart around in this window that you have if you want to focus on a particular area. But this is a very simple chart we have created, so not much useful. You can select using a box select. Okay, wherever your box is. Okay, that particular bar will get selected. Okay, I can change the region. Everything gets reset. I can go to lasso select, and let's say I select a particular category. Okay, now I can also auto scale this. It is already auto scaled. Show closest data on hover and compare data on hover. Now, all of you must have studied what are line charts. So let's say you have a line chart over here, which looks something like this. There is one line which is, let's say, a green line, another is orange line, another is blue line. Here we have bars. So what happens is, in case of a bar chart, for every point on x-axis, you'll only have one category. In case of line chart, what you can have is you can have multiple categories which are plotted at the same time. You can have multiple lines, each denoting a separate category. So every point on x-axis, in that case, if it is a line chart, every point on x-axis will have data about all three categories. It can have data about all three categories. So in that case, we can compare all three categories on hover. You will get a vertical line which will help you compare all three categories or all two or five, whatever categories are there, a number of lines. Okay. In this case, compare data on hover is not applicable, and then it is produced with plotly.js. If you have any questions, any doubts, do post them in the comments below. Thanks for watching.